Good morning, everyone. Welcome to this webinar of the EUCloudEdge-IoT initiative, specifically Unlock CI project. My name is Maria Giuffrida. I will be, let's say, the moderator of this event, and I'm very happy to welcome you all. We are just waiting a few minutes for everybody, let's say, to connect. While we wait, let me just give you a few information about housekeeping that we generally follow for online events. So the first information I want to give you is the event will be recorded, and the slides and also the let's say presentation will be available on our website as soon as it ends. But you can use the chat and the Q&A box whenever you want to give your comments, your questions for the panelists, and we will make sure to follow up in written form or in oral form as soon as possible during the event. Also in the chat, we will put other useful links or information that you may want to check to go deeper and analyze better the information and the resources that the speakers will talk about. Then I want to give you an overview of the agenda that we have for today. We have a 2-hour online event. Although it's online, we hope it will be easy for you to interact and ask your questions and follow through all the sections. We will have a first part that's mostly presentations on various topics. So we'll have an overview of the project, very short, but also an overview of cloud edge and IoT market trends in mobility and transportation by Golbupur Abdollahian from IDC, who is the coordinator of Unlock CI. Then we will have a presentation about value chain dynamics in the mobility transportation sector by Caroline Zackhaus from PDI, that's also partner of the project. And then we'll have a presentation on the initiatives around European data spaces for mobility by Stephanie Feder from Acatech, because in this event we are trying to showcase not only cloud edge IoT innovations and use cases, but also provide some synergies with connected initiatives such as the ones about data spaces in vertical sectors. Then we'll have a second part, which is a presentation of various use cases on cloud edge, IoT, data space, and also connected technologies like AI from research and innovation projects. And so we're very happy to have 5 different projects presenting their use cases. We'll have Nebulos, ICOS, Nefele, Iros, and MobiSpaces project representatives. And then the use cases that are presented in a more formal and detailed way in this session will be discussed and expanded in a panel discussion with presenters from MobiSpaces, G&D company, and Nefele and ICOS. I will introduce each panelist and use case presenter properly later on. And then we'll have a final Q&A and wrap up. We'll aim to finish no later than 12. But as I said in the beginning, do not wait for the final 15 minutes to ask your questions. Use the chat and the Q&A box whenever you feel you have something to add or ask. So this is the, let's say, menu of this morning. And I think I can now stop sharing my slides and leave the floor to Golbu for her introduction. Thank you very much.
Thank you very much, Maria. Yeah, and also a welcome from my side to all the participants. Do you hear me?
Yes.
Okay, perfect. Let me just start sharing my screen. Okay. Sure. I hope you can see my screen.
We can.
Okay, perfect. So my name is Golbupur Abdollahian. I'm a senior consulting manager in IDC, and I'm the coordinator of the Unlock CI project. I'm going to provide an overview about the Unlock CI itself, and then some market trends and insights that we have generated within the Unlock CI in terms of the mobility sector. So Unlock CI is a CSA, is one of the CSAs that is under the umbrella of EUCloudEdgeIoT. EUCI. So EUCI is a European initiative which has been established by the European Commission through two CSAs, Unlock CI and Open Continuum. And the main objectives and the purposes of this initiative, I mean, we can say that first of all, the initiative tries to create a more consolidated understanding of the technology development and also market understanding in terms of cloud edge, IoT, and computing continuum. And then there are different clusters of the projects under the EUCI, not only MetaOS. MetaOS is one of the clusters. And so one of the main, another main objectives is to promote cooperation and collaboration between different projects and different stakeholders across the community. So from the research stakeholders, to industrial stakeholders, to end users, etc. And finally, to support the definition of the large-scale pilots. As I mentioned, there are two CSAs who are the pillars of the EUCloudEdgeIoT. Open Continuum CSA, which covers the supply side of the computing continuum, and Unlock CI, that we're talking about it today, that covers the demand side of the computing continuum. In Unlock CI, basically, the main objectives that we have in the projects is to provide knowledge and generate knowledge in order to facilitate and accelerate the deployment of the solutions, of Cloud-Edge-IoT solutions that are being developed within the supply side, so within the projects, and providing insights in terms of the business opportunities, in terms of drivers and barriers, and support the MetaOS projects to understand these insights, that what's happening in the market, what's going to happen in the market in the future in Europe, and so they can move towards the exploitation of their solutions in an easier way to ensure that they are gonna satisfy the needs of the users. So the 5 main objectives that we have, as I mentioned, if we want to go into detail of that, is the assessment of what's happening in the demand landscape in the computing continuum, then definition of the market and scenarios and guidance about what's going to happen in the future in the European market for computing continuum. Also establishment of the dialogue between the supply side and the demand side, so the momentum with the industrial stakeholders, and eventually raising awareness and impact generation. We target 5 main sectors within Unlock CI: agriculture, energy, healthcare, manufacturing, and transportation. And we are almost at the last mile of the project, so we're going to end at the end of November, and so I think that now it's really a good time to demonstrate most of the results that we have generated within the project. So I will start with some initial insights from the mobility market and from the computing continuum market overall. So as you can see here, the market for the Cloud-Edge-IoT in Europe is increasing, and this means the spending in the market, the investment that European companies are making in the market. So here you can see that overall in 2022, there had been almost close to 300 billion euros invested in the Cloud-Edge-IoT. Obviously, the biggest part of the investment has been in IoT part, and then cloud, and then edge. So as you can see, edge has the smallest share. But what is interesting here is to notice the compound annual growth rate of the investment till 2026. So as we can see, the growth rate for edge investment in Europe is something around 14%, which is quite significant. So the expectation and our forecast is that I'm sorry, let me just put myself on do not disturb. Okay. The growth rate for investment in the edge will be really significant in the future. On the right side, you can see the current adoption of edge technologies across different sectors, and also the plan of different sectors in order to deploy edge. So you can see that overall we have a low rate of adoption, around 6%, which is understandable because edge is more or less at its beginning of its journey to be deployed in the market. And we can see that in different sectors it's different. For instance, in sectors such as healthcare, and manufacturing, it's even more advanced. But in transportation, we can see that the adoption is still low, but the green part that you see here, 39%, is the plan of the European companies to adopt edge solutions in the next 2 years. And so you see that it's quite significant. If you just compare it with the other sectors, we can see that in mobility and transportation, the future potential of the adoption of edge is more compared to the other sectors. So the message is, even though currently there is not much happening in the mobility sector in terms of the adoption, but the results of the survey that we did in Unlock CI shows that in the future there will be a big potential to adopt edge solutions. But what are the benefits that will be brought by edge computing to different sectors? And here specifically today, we're talking about the industry. So here, if you look at the right side of this graph, which is targeting transportation and mobility sector, we can notice that the main advantage and benefit that European companies are seeking for by adoption of edge is related to improvement of security and compliance. Since when they use edge, data is not going to travel, it's not going to travel as much as before that they use only cloud across the different nodes. And so this has been one of the most important benefits that they are seeking for. Another important benefit that for mobility is really important is the very low latency. And if we consider, the dynamics of the mobility and transportation sector, that it's really the field is really not limited where the devices are established and where the data can be transferred, we can understand that why these two benefits are really important for the mobility sector. And if we can look at the right side of the slide, this shows us, this is, again, these are all the results of the analysis that we did in Unlock CI with the survey. This shows us that the adoption of the use cases in mobility and transportation sector. So here we can see that there are some use cases such as fleet tracking, such as video security, such as freight monitoring, that are being quite deployed and adopted to a considerable range in the market. However, there are other cases, other use cases, such as AGVs, for instance, which currently are not much adopted, but the potential for their adoption is quite big. So again, this helps us to understand that the future of the edge market in mobility sector will be mainly based on spotlight use cases, which means that not only the use cases that are being currently adopted are mature more or less and are going to be adopted even more in the future, but also the ones that are not currently adopted, but with the advancement in the edge solutions, interoperability and everything, they are going to be adopted in the future. However, there are also challenges. So there are different challenges that companies, especially small and medium enterprises, face when they want to move towards deployment of the edge. As you can see here, the first challenge that was the result of the analysis was the high cost and unclear return on investment. Basically, till now, the business case is still for adoption of Edge is not there for all the cases, all the use cases. So it's something important to understand that if we at the supply side, if we will be able to develop the most sophisticated and perfect solution, till there won't be a concrete business case and a clear return on investment, it's going to be difficult to adopt it in the market. Then the second challenge that they're faced with is the security concerns. Again, with mobility, it's something which is important, and also lack of adequate IT infrastructure. If we look at on the bottom of the slide, the challenges are being categorized based on the responses that we received per sector. One interesting observation here is that mobility and transportation is the only sector that has highlighted incompatible components as the main and as a top challenge. So it seems that, you know, interoperability and integration is really a very important issue for mobility sectors to move towards Edge and to be able to distribute the workload across the computing continuum. Then obviously there are other challenges such as lack of adequate IT infrastructure, lack of skills for workforce, return on investment, and security concerns, as we mentioned. So basically, the message is that even though the future market forecast shows that there will be a good investment from the market towards Edge, but there are still challenges that we should address, you know, before reaching to that point. And this is really what we try to do in Unlock CI. We don't have much time today, but I would invite you to read our reports and white papers that we have on the websites or on different topics and about the results that we have obtained within the projects. And yeah, that's all. Actually, I had another slide that I think that it's not here. Maybe I forgot to put it, but I just wanted to invite all of you also to register and attend the final event of Unlock CI, which is going to happen on 23rd of September in Brussels, so prior day to the EUCloud days. If Maria can kindly put the link in the chat, that would be great. Again, I'm sorry that I forgot to put the slide here, but I hope that we can see you there. Thank you very much. Maria, to you.
Thank you. Thank you very much, Golbu. Yes, I put the slide, the link in the chat of the reports you mentioned, and also the final event we're gonna have in Brussels next to the IoT days. Maybe I'll project a slide about this at the end of the event again. Now we can go on. I don't see questions specifically for this part in the chat. Only there was a question about slide sharing. I confirm for those who connected later that both the video and the slides will be on our event page and on Zenodo as downloadable files. And now we can go on with the agenda. So I leave the floor to Caroline from VDI for the presentation on value chain dynamics in mobility. So Caroline, the floor is yours. Can you hear me, Caroline? Okay, I cannot hear you, however. No, indeed. Am I the only one facing struggles because they...
No, I cannot hear as well.
Oh, okay, okay. So I believe, Caroline, you have some issues, technical issues. Okay, I see you now, however. So let's try. I'll ask you to activate the audio again.
Can you hear me now?
Yes, now it works.
Great. You
So
try
that's
everything beforehand and then it's not working anyway. Okay.
yeah,
Now I also share my screen because who knows if this is going to work now.
yeah. Let's see. No problem. We have some time to.
Okay. I think it should be working now, right?
It does.
You
Perfect.
screen and the full version. Okay, perfect. So yeah, sorry for that. I guess it's always good to have some technology and try it out first, and then it's not working in the moment you need it anyway. But yeah, I want to say a few words on the market dynamics and opportunities for different European countries in combination with Cloud-Edge-IoT and the transportation sector. I'm presenting this now, but I also want to give some credits, or most of the work actually has been done from my colleague Jörg Dubbert, which is also working at VDI-VDEIT. So if we look at the key trends of IT, I mean, I assume all of you know them, but I still make a short mention that like the key trends listed here, like increasing computing and networking power, but also distributed software architecture, availability of like mobile devices, computing continuum, and different aspects related to data in terms of real-time data, data hubs, and different access points, as well as AI, machine learning, and digital twins. And on top, the quality of digitalization supports different upcoming market trends in the mobility sector, which then promote actually high quality, efficiency, performance, and safety of our future mobility systems. We see a list of different mobility trends that come up in the mobility sector. So these new technologies on the left-hand side support things like the software-defined vehicle, very hot topic lately, but also the implementation of electric vehicles and automated mobility, as well as different AI technologies support different traffic data detection, but also the processing in new generations of multimodal agent-based traffic management systems. We see more upcoming shared transport services, but also the concept of mobility as a service, which then need different aspects of course, data sharing as a possibility, but also the cooperation of different types of stakeholders in the public sector, but also for shared transport services, we need the fleet management in that regard, and of course also a booking system. And then maybe in the future, we see even more disruptive trends and approaches such as hyperloops, driverless air taxis, and things like that, that all highly depend on digitization, cloud edge, IoT, and automated approaches. Yeah, Golbo said it already pretty much. What are the specific or different challenges in the mobility sector? I just do like a brief summary also from my side again. So we see that the challenges of Cloud-Edge-IoT are starting with the economic viability of the solutions, but also with the need of showing or offering clear added values to technologies that are available already now. We have a really huge or like a great complexity for the implementation of reliable, plausible, as well as failure-safe transport and real-time traffic management. We see, of course, the need of safety for all the operations. Security concerns are mentioned very often in terms of data protection, cybersecurity, but also privacy for the end users at the end. And we have still a certain amount of lack of unclarity of governance and regulatory frameworks. And then I think what Golbo also mentioned, the lack of adequate IT infrastructures. So what we've done from our side, we look now at certain example use cases to demonstrate the current changes in the transport and mobility technologies. And we see that in the automotive industry, as I mentioned also before, software-defined vehicle is a very yeah, present approach, I would say, is discussed very widely. And then also we see, of course, cooperative intelligent transport systems is also discussed very heavily and is a great way to, yeah, increase the efficiency of vehicle development, but for the software-defined vehicle, but then also the efficiency of operation and the optimization of the traffic system. I will start with the software-defined vehicle. So this new concept, or it's like, yeah, rather new concept that is a great great example for the deployment of CI systems. And we see that the computing systems of the single vehicles are designed as a edge like platforms for a variety of different connected vehicle-based sensors. And then we see from the data side that the data from the vehicles is basically, yeah, is the basis of continuous optimization and development of the software. The vehicle software is then regularly updated from a cloud-based platform. In order to implement this software-defined vehicle approach, there are usually different players from the one side coming from, yeah, more the ADAS side, so the advanced driver assistance systems. But then we also need actors from the field of the automotive hardware, as well as the software development. And we also see that the cloud hyperscalers are actually cooperating in this ecosystem. We can see here an example from the Continental Automotive Edge platform. We see that in here there's a cooperation between AWS, Continental, and Electrobit, where we see that AWS obviously provides the cloud-based services, and then Continental and Electrobit deliver the more vehicle-related, on the one hand, hardware from Continental, and then Electrobit, the software side. If we look now, yeah, on the one hand side here again, there's a graphic on like new players such as software vendors and chip suppliers that are cooperating, as I mentioned before, with the cloud hyperscalers, and that are then becoming direct partners with the OEMs. But we see also that there are a set of different cross-domain enablers, technology giants, and also traditional suppliers that are complementing the approach or the idea for software-defined vehicles. And if we look at the opportunities for this approach, we see, in addition to the right enabling technologies and the separation, which I think is like a main point of the hardware and the software side, which is the basis for the software-defined vehicle, we see that this can accelerate the innovation cycles, and then it also in turn saves time and costs in the development. It's a little bit like if you look at a mobile phone and you see you can like add functions or delete functions as you please, so to say. So thus equipping also the car with special functions that provide, for example, I mean, more safety, of course, is like a key. But I think also the OEMs look for more user experiences, because at the end they want to sell the vehicles to their end users, and also, of course, to more sustainability in the vehicle. We see some further opportunities as the cloud-based processing and analysis. Of course, we have like AI in the cloud to validate detected objects against test data, and then with that enable the approval of new software updates more quickly, but also more reliable. We have simulation support through cloud storage and data pipelines, and also edge platforms for the development. And of course, also one topic that comes more often into the discussion is the digital twins for simulation, testing, and certification of vehicle electronics. As well as we see open modular platforms also as an opportunities for SMEs to collaborate with the OEMs. And we see the development of standards and open source solutions through industry task force, for example, like Eclipse and Suave. However, there, of course, where there are opportunities, there are also always specific identified challenges, and they kind of align a little bit with the overall challenges, I guess, for Cloud-Edge-IoT also. But to mention like some more specific ones, we have the challenge of addressing data sharing aspects. Also from the business model perspective, so to see where there can actually be a valuable business model for the data sharing, and where do we actually ask for more open solutions for data sharing and value generation, as well as where can we implement open interfaces for the implementation. Furthermore, a little bit as mentioned before, the managing complexity, but also new architectures, the integration and the life cycle are the main pain points that need to be solved in this regard. If we now look at our second use case, which is the traffic management and the CITS, we identified a promising example in Hamburg, which is a cooperation from Consider IT and Hetzner. Here in this example, Consider IT provides an edge-based platform for the management and maintenance of CITS services, as well as for vehicle to infrastructure roadside units and vehicle on board units. And then for the cloud services, we have a provider which is called Hetzner, like from the European side. So it does not necessarily need to be one of the big well-known hyperscalers. So this means this is actually a great example for the deployment of the system architecture approach in like the road traffic management, also with like an entire cooperation or all the stakeholders coming from within Europe. We see the roadside and onboard units are integrated in an urban edge platform, which enable then the traffic management services. For example, like green light, optimized speed advisory, time to green, but also signal priority requests, roadworks, warning, and route advice, and other services and applications. The system also enables data security, and it provides an open interfaces to data exchange platform, especially through or for public and national authorities. And I think with that, I'm also coming already slowly to the conclusion from our findings. So we can actually see that there is a chance for Europe also to start or to get more into the development of intelligent edge solutions which are based on the sector-specific know-how in the mobility sector, and then related to IT industry. We could see like the different approaches that I just showed to you. So we have the example of Continental, where we see a cooperation with a close cooperation with a global hyperscaler for the implementation of the cloud services. And then we see the edge solution coming from Continental as the owner of this specific know-how in the vehicle electronics. And then we see the example of Hamburg, where we see that we have an innovative, highly specialized European SME, which builds services on the edge, including hardware and software, and they cooperate with a cloud service that just comes as a side service, but from like a European provider. And what we conclusively or finally can say that it's very important to guarantee the access to, of course, data spaces, open data, and standardized interfaces. And it's easier to, or maybe it's not easier, but it can be implemented also with the will of the public sector, and then in combination with private industry. And the potential for European edge providers we see is the development of sector-specific solutions, and then with that to protect actually newly developed know-how and use the cloud functions more as a tool to develop their new sector-specific edge know-how and knowledge. I also summarized the ideas for different European R&I projects, or also pilots that were already, they were already put out. So the cooperation, of course, between OEMs and supply chain is important for open interfaces, and then also standardization always plays an important role. And with that, I would like to thank you for your attention.
Thank you. Thank you very much, Caroline. If there are any questions from the audience, feel free to ask them in the chat or in the Q&A box. In the meantime, let's go ahead and let's go on and let's move to the data spaces for mobility. So I invite Stephanie Federl from Acatech to share the slides and start with the presentation. Welcome, Stephanie.
Thank you very much, and thank you very much for the invitation. Good morning to everyone. So I would like to share my slides. I hope you can see it now.
Yes, we see your slides. Yes.
I moved to full screen. Okay, so yeah, thank you very much again for the invitation. So I would like to present today our project that deploy EMDS project. So my name is Stephanie Federl. I'm a strategic project manager at Acatech, and Acatech is responsible for the coordination of the deployment action of the European mobility data space, and we are working towards a common European mobility data space. So Caroline, also thank you very much for your presentation, and you already emphasized the challenge of data sharing efforts. So that is what we are working on. That is where the data space comes into the picture, and we are doing that on a European level. So first of all, I would like to briefly introduce you to the context of it. So within the European data strategy, the European Commission has the aim to work towards a common European data space, one single market for data. And for that reason, they would like to establish different common European data spaces in relevant sectors. And that is, for example, in the field of, in a domain of mobility. There are already different initiatives in the picture. So also as a coordinator, Acatech was involved in the PrEP-D space for mobility, a complex name of the project, and that was the first study figuring out what kind of initiatives are already out there in Europe, but I will come to that in a minute. And there is also a CEF technical support study going on. They are rather focusing on the technical and governance dimension and developing an interlinking layer between existing data spaces. And there is the deploy EMDS action we are currently working on. So as already mentioned, we started also as a coordinator with the PrEP-D Space for Mobility project. That was a project for 1 year from October 2022 until September 2023. There were 17 European partners involved, and the goal was to map existing data ecosystems, so to identify what kind of data platforms, data spaces are already established in Europe, and we identified more than 400 and included in this mapping, identified according to specific criteria, 272 to be exact. We analyzed these data ecosystems and also published analysis report with recommendations towards a common building blocks for a future EMDS. And right after finishing that project, we started the Deploy EMDS project in November 2023. And that is a project for 3 years. So it's a much bigger consortium with 45 European partners. The goal is to build a decentralized technical infrastructure as well as common governance mechanisms on the basis on 16 different use cases in 9 cities and regions across Europe. And we are focusing on urban mobility topics. So all of the use cases are tackling specific problems in urban mobility. And why are we doing that? So there, you might be aware of the challenges. And like I said, Caroline has already mentioned some of these. So mobility sector is indeed a sector, very data intensive sector. So there is already a lot of data out there. However, it is very fragmented. So our goal is to establish a metadata catalog in order to make these data what is maybe locked up on regional level or in silos to make it discoverable and accessible. And what we also realized is that there is the challenge to that data providers are reluctant to share their data because of security concerns. So we are also working on a trust framework so that the providers can decide what data is available from whom and under which conditions is it shared. We also face the challenge of the lack of interoperability between different data types and standards. And we are also working towards convergence, towards common standards and harmonization on a European level. And that should also facilitate new data-driven solutions and business models. So to summarize that, so our goal is to retain the authority and the control over the data through the European mobility data space, to make data what is already out there discoverable and available, and to share and exchange data in a standardized way. And how we are exactly doing that, so like already mentioned, so really the heart of our project are the 16 different use cases, the real-life implementation projects. So we would like to learn from that, what are their needs and requirements. So on the one hand, the urban data governance challenges, which should be addressed, but also to understand the technical requirements. And that is what we are currently doing. So we have a lot of different workshops, interviews, sessions in order to understand. So what we already analyzed, the technical requirements, but also we have policy labs to understand the specific data governance problems. What is actually really a complex topic of our project. So because we are not only working with open data, but we are also working with non-open data, and that requires specific consideration of data governance. And what we are learning there and what we are developing, of course, goes back to the real-life implementation project. So we do not develop new components or standards. We rather take existing and use existing standards and components, but we select them on the basis of the needs and requirements of our cities and regions, and we will implement these in the implementation sites. So I also would like to give you a little overview, but I will briefly go through that because I think there is not so much time left. So as I already said, it's about 36 months. We have a budget about 60 million euros, and that is co-funded by the European Commission. And we have 38 beneficiaries involved, as well as 7 associated partners. So these are cities, regions, and technical and domain experts. And here you can see a little overview. And that is the setup of our project. So here again, you see the center are the real-life implementation projects. So as I said, there are 9 cities and regions involved, like Barcelona, Budapest, Flanders, Ile-de-France, Lisbon, Milan, Sofia, Stockholm, and Tampere. And on the one hand, we have the development of the common technical infrastructure, what is led by Fraunhofer. And on the other hand, we have the development of the common governance mechanism, which is led through RISE. And we also have Ertico, who is our partner for communication, dissemination, and exploitation. And on top of that, we also have an innovation and scaling group, as well as a group of follower cities. So because, of course, we don't want to really isolated work on the European mobility data space, we rather would like to involve also the industry. For that, we have the innovation scaling group, where we involve the industry, SMEs, and data innovators, startups, to also learn from them and also to inform them about our developments. And we also have follower cities to make them to give them the possibility to learn from our developments, but also to see their current status and understand their challenges. But I also would like to introduce you to some of our use cases, because in particular, IoT plays a significant role in our use cases. So as already mentioned, we have this different 9 different cities and regions involved with 16 use cases. So each city has 1 to 3 use cases, and they are focusing on these different topics. So we clustered them. So we have, on the one hand, public transport operations. So for example, in Barcelona, so they would like to improve their fleet management. In Lisbon, they would like to improve the routing of their buses within the city. And then we also have data for mobility planning. I will introduce 2 different use cases here because, as already mentioned, IoT plays an important role here. For example, for Flanders, when optimizing the reuse of traffic measurement data, and as well as Stockholm, who would like to introduce 0 emission zones and measures to reduce car traffic. And then we also have multimodality use cases. So for example, Budapest, they already have the Budapest Go app, which involves data and travel information from public transportation in Budapest, but they have not involved yet other third parties like micromobility providers. And so their goal is to exchange data with them through the European mobility data space. And the 4th cluster is specialty travel information. So for example, Lisbon would like to enhance the seamless route planning for people with reduced mobility. So for example, they would like to collect further data on measurements on sidewalks and so on to make the travel experience, to enhance the travel experience for people with reduced mobility. And we also will establish 2 transversal use cases because we would like to bring all of the cities together, and we would like to tackle, so it is planned, but we have not decided yet what will be the focus of our transversal use case, because we are in month 7, I think, or 8. But the focus will probably be on multimodality. For example, it could be like open public transport ticketing. And then the second use case focuses on the sustainable urban mobility indicators, because we also, of course, have sustainability goals involved in our project. So now I would like to introduce you briefly to 2 of our use cases, which might be interesting for you in your context. So for example, in Flanders, focusing on traffic measurements. So there is already a lot out there. So there are already collecting a lot of information through IoT sensors on infrastructure like traffic cameras, speed sensors, or vehicle counters. However, this is mainly locked up. So the sensor to analyze its value change is often linear and closed. So the data exchange occurs bilaterally or ad hoc or with local data applications. So there is a limited access to this kind of data. And the objective is, so they are already have developed an own data space in Flanders, so a local data space, and they would like to further develop this data space and interlink this and connect it to the European mobility data space in order to make the data on traffic measurements exchange possible across borders, so also with other regions and cities and countries, and to also improve the usability for data consumers, like I already said, to make the data discoverable and accessible. And then the second use case is in Stockholm. So they also have already important data collected through traffic count data, for example, and or air quality, and they make it accessible through their public data portal or their open innovation platform. However, they see great diversions in the adoption of governance models, and they lack standardization of the data formats, though they are there in a very different format. And some of the data is they need for the introduction of the zero emission zones is not already collected. So their objective within the Deploy EMDS project is to provide high access to high quality data to evaluate this zero emission zones to by combining the already existing one, but also collecting the new data. And they want to also integrate them into the Stockholm mobility data space. So also here they are already, or they started to develop their local data space, and they want to subsequently share it to the EMDS, the European Mobility Data Space. These are here two examples which are developing an own local data space. However, that is not always the case. So that is still a question which remains, but we are currently the ambition, the aim is to work towards a federation of existing data spaces. However, we are still in the process of learning and about that, about the needs and the requirements, and we will still see where we are going in this and how the European mobility data space will exactly look like at the very end. However, the Deploy
Stephanie, sorry, we need to come to the conclusion.
Okay, sure. Okay, I just wanted to say that we see the strategic alignment highly relevant, and we see a lot of synergies. Also, what I already learned from the presentation before. So, because we can provide very important insights from our 16 use cases, and so we are really looking forward to continue working together and to learn from each other. So, thank you very much.
Thank you for your rich presentation. And now with your presentation, we are finishing, let's say, the first part of the webinar. We now move to the presentations of other use cases. You mentioned a few examples, but now we have, more details on use cases from other projects. So I invite the first use case presenter, David Martinez from Nebulous project, to share slides and, of course, to present the use case. You have 7 minutes, David. Thank you.
Good morning. Can you hear me?
Yes, we can.
Okay. Thank you for the introduction. I will share my screen. Okay. So good morning to everyone. I'm David Martinez from Mercabarna, and I'm going to talk to you about fresh food supply and last mile optimization with Nebulous. So first of all, let me explain what is Mercabarna and how it works. Mercabarna is the largest wholesale market in Southern Europe and one of the biggest in Europe. And it is a fresh food hub with more than 600 companies specialized in fruits, vegetables, fish, meat, and flowers, and from big trucks to vans, cars, or forklifts work together to carry on customers' operations every day, 24 hours a day. And approximately 13,000 vehicles access the food unit every day, of which 7,000, that are more than 50%, are commercial vehicles. And of these, 1,000 are large tonnage vehicles. So the problem we have is that entry and exit windows typically align, and making an effective internal traffic management is a must to prevent traffic jams and bottlenecks. So our solution with the use case to prevent that is to develop a real-time traffic monitoring system. And as you can see in both images, a network of CCTV cameras installed at road intersections records traffic flow in both directions, and that strategically cover the most critical areas of the market. So we can see the vehicles that goes through the road, their license plates, and see all the traffic. So the CCTV cameras stream videos within our internal network, providing us valuable information. And with this information, we are able to ensure smooth operations and prevent the traffic jams and bottlenecks mentioned, and also maintaining a cleaner and tidier environment that will make life of our workers, sellers, buyers, and visitors easier. So this is the architecture of our solution. The solution is divided into two applications, the video stream application and the management application. And the process would be the following. The vehicle detection and cropping module consumes the video streams from the cameras and creates vehicle crops, which then sends to the message broker. The license plate detection and reading module reads from the message broker, where it can find crops from all the cameras. And from these crops, it tries to deduce the type of vehicle, the license plate, and when it has done that, it anonymizes it and saves it to our database that is in the management application. And with this historical data that has been previously cleaned by the traffic reconstruction module, we can simulate the traffic by changing, for example, the direction of some lane. And finally, we have the data history and the simulations that can be viewed from a web application. So this is the current state of the web application. You can see that we can select time intervals and view how the traffic was at that moment. And we can clearly identify the critical zones. And we also have a comparative analysis window where we can see different days, different hours, and compare how the traffic was. So how Nebulous helps us with this use case? Nebulous is a meta operating system for brokering hybrid distributed applications on cloud computing continuum. And Nebulous can decide for us at any time the application deployment topology. Usually the topology of the application is the one you can see here, with the vehicle detection and cropping and license plate detection and reading modules at the edge, the broker, the traffic reconstruction module, and the database at one cloud provider, and the simulation module and web at another. So as mentioned, Nebulous can determine the application deployment topology at any time, allowing it to detect any module requiring more resources and reorganize them accordingly. So in this case, I put an example that usually occurs that during peak hours, where the license plate detection and reading module is moved to the fog because it has a lot more data to work with. And Nebulous also helps us scaling the module instances. So sometimes, no matter how many resources we allocate to one module, it might not handle all the load. And in such cases, Nebulous creates more instances of this module, which will also consume messages from the message broker and distributing the load among them. So in conclusion, this use case will help optimize traffic management, resulting in smoother traffic flow, reducing congestion, and fewer bottlenecks. It will also enhance stakeholder satisfaction by improving the experience of Mercabarna sellers, buyers, visitors with a cleaner and tidier environment. And with Nebulous, we can enable agile deployment for us, empowering an easy and adaptive adjustments to evolving environmental conditions. So here we have the different pages of Nebulous. You can follow us, and thank you for your time.
Thank you. Thank you very much, David, for the presentation of the use case. We can go on and maybe see if questions arise at the end of the use case, pitches. So I move to ICOS project today, represented actually by two people, but for now you will meet Isabella first. So Isabella Zrazinska for the railway use case of ICOS. The floor is yours, Isabella.
Perfect. Thank you very much, Maria, for the introduction and for the invitation. So as already said, I'm Izabela Zrazinska, and I'm the Innovation Project Manager from World Sensing. And also we have with us Carles Miraples from FGC. So we are the use case from the ICOS project. So basically this is also the meta operating system. So I'm not going to enter into the details about the ICOS because I believe the projects are quite the same, but I'll tell you a bit more about the railway use case through which we actually test and validate the platform. So within these two partners that we represent, the World Sensing, we are the leader in the wireless geotechnical structure monitoring. That means that we have a part of Edge, so we have the special devices that are wireless sensors that communicate through the LoRa networks that allow this long-range intercommunication. And also what's important for them is the robustness. So we work a lot with difficult industries like mining, like railway that we'll present today, construction, and also civil infrastructure. So our sensors or monitoring solution used a lot in the bridges, monitoring and so on. And we also have a part of the edge, and then we have part of the cloud, which is the software, which is we call it connectivity management tool. And I'm explaining that because this is also part of the use case. So I will show you later the architecture where you will see all these parts of these devices. And the problem, so for we are much, or we collaborate with FGC because they have the infrastructure where there are holes in the ground under the railway. So it's a big safety problem, and in terms of the costs, for now the monitoring solution are the visual inspections in person mostly. So of course it takes time and money to send people there. And also there are many repairs needed on that track, and it also influences the operations, right? Because the train has to slow down in that part. So also if the monitoring can be in the real time, it will allow this to work better. As for the installation, so we already did that. So here you can see all the devices. They mainly monitor the cant and twist, okay, so of the railway, also the subsidence, so all the ground under the railway. And we also have this, so these are the tilt meters mostly, and extensometers go down in the ground. And the gateway, and this is important for this edge device that actually is the communication hub that we use now to send the data to the cloud. And this is a key point also for the ICOs. Here, well, you can see the data we're receiving. And here's the architecture that maybe explains a bit better where the ICOs is. So you see the sensors on the railway, and you see that they are using the LoRa network, and they're sending data to the edge device, which is this gateway that is also located in the track. The gateway is using the 4G connection and is sending the data to the cloud, and is available to, and then through the CMT Cloud application, it allows to manage and also see the data for these devices. And important also for this context of this use case, this application is also triggering the alerts, okay, if something is happening. And what we want from ICOS, or why we are in this project, is because that zone, and also it happens in many railway zones, that sometimes they're in the remote zones. So there are difficulties with the connectivity. So here for us, it will be important that in case the connection between the gateway and the application or the cloud is lost, so we want that the alerts are triggered anyway. Okay, so this is for improving the safety on the railway. It is important. So that's why we need this edge part and triggering alert part to operate regardless the connectivity. And another plus for us would be also between these two, between edge and cloud, if the system could help also to make the decision on transferring the data to upper layers, depending on end user needs. And for now, while we are doing the ICOS, we are setting up all the systems. So as I mentioned, infrastructure is already done. So you can see here part of the application and also the gateway. Indeed, as for the difficulties so far, I would say that, of course, the edge devices, especially because they are wireless and, because of also the battery use, sometimes the processing capabilities are quite low. So I have to admit that this will be a challenge, but of course, this validation part is for that, to test that part. And also we are working on this application deployment, that it has services microservice architecture. So we are also looking on how to deploy it in the ICOS Meta operating system. And by the end of the project, I hope we will be able to test all the solutions. And that's it from my side. So here are our contact details to me and to Carlos, who will be joining the panel session later on. Thank you.
Thank you very much, Isabella. I will put the link to ICOS also soon in the chat so people can read more details. And now we move on to the next speaker from Nefele project, or also part of the Meta operating system cluster with ICOS and Nebulos. And so I invite Rudolf Sunsik to share the slides that are already there.
Hello.
Hi,
Can you see my slide already?
Yes, we can.
Okay,
thanks.
Thank you. So in the Nefele project, we are developing a lightweight software stack and a synergetic meta orchestrator. And one of the 4 use cases where these outcomes will be tested is also the use case on AI-assisted logistic operations in the port of Koper. So considering the Nefele project, so similar to also other MetaOS projects, there is one of the challenges is which we are trying to solve is a need for the convergence of the IoT technologies, which will be implemented through the development of IoT and edge computing software stack, which actually means that we are providing, or we will be able to provide the kind of open environment for connecting any kind of the IoT devices. And another project, another challenge which comes out of this is to have the ability to orchestrate the complete software stack, which also includes the application which utilizes the data collected from the IoT devices. In a general perspective, this means that we are dealing in a kind of a system of systems approach, where at the bottom layer we have IoT devices, which are then logically represented with the stack we are developing, and which serves as a convergence layer and providing the data to the applications. And in the other way, like in a top-down perspective, as we also already heard from the other projects, there is also a need on how to orchestrate all the applications and all the software to provide the maximum effect for the problem we are trying to solve. So one of these problems is, as already mentioned, assisting the logistic operations in the port, where the main objective is to optimize the routing of the cargo containers from the container terminal. So the cargo containers are arriving or leaving the port by ships. So and then so the majority of these containers goes out of the port by train or by trucks, but there is also a certain amount of the containers which need to be first delivered to the warehouses, where some additional business process takes place. And the idea here is to optimize this process of delivering the cargo containers from the terminal yard to the warehouses. So meaning that at the end we want to reduce the routing times, which will affect also the carbon footprint, the utilization of the equipment used, and of course will improve the service itself. So one may think that the traffic in the port is something which is not very challenging, but the fact is that it's pretty challenging when dealing with so many containers. So for example, on a daily basis, there is up to 1,000 containers that need to be delivered to different warehouses. So taking this into the account, as already also mentioned, the main problem here is to identify the optimal route for the trucks which are delivering those containers. And there is also another vehicle called Reach Staker, which takes care of putting the containers to the truck and from the truck. So all this problem can be is supported by collecting the real data in the field. So this data then serves as the input to the optimization process. So what we collect on the field, or what we will collect on the field, so at the moment the development is mainly based on the laboratory environment. So we will survey the area. So in order to have a overview how many slots are available at the warehouse areas, what is the situation with the traffic in the port, and then we also have some supporting sensors for providing data on the radio network performance, geolocation, and environmental data. So this data collected from the sensors in the field are not the only thing which affects the optimization process. There are also other business-related process data like customer requirements, availability of vehicles, and so on. And all this should work in a real time, or at least in a near real time. So that's why we use a 5G network and we utilize the Nefel Cloud-Edge continuum approach. And as well, we include here the time sensitivity network features to our stack. So just to have a brief view over the stack we are developing. So as mentioned before, on the, let's say, the lower physical layer, we have IoT devices, which are then represented, one or many of them, so it depends on the functionality, with so-called virtual objects, which also add some add-on. So that's now already the physical, or not physical, it's now a virtual representation of the virtual objects, collecting collecting data from the physical IoT sensors, which are then functionally combined to composite virtual objects, and this then provides data to the application itself. So this software stack also follows the physical integration, where we have a far edge, and cloud. So to conclude, the expected TRL of the project is 5 to 6. So at the moment, or at the end, this will be, say, more the proof of the concept and will be tested in a real environment. But however, through this, we want to prove how much we are able to reduce the delivery time, how much can we increase the utilization of the equipment in the port, is how can we affect or reduce the delivery errors, and as well how can we improve the environment by reducing the CO2 emissions of the vehicles used in this process. So that's mainly all, and also here is a colleague, Yuri Mirnik from Luka Koper, who will contribute in the panel session. Thank you.
Thank you very much, Rudolf, also for anticipating in your final slides some of the issues and topics we will discuss in the panel with the Yuri and the other speakers. Now let's go to the next use case presenter from IROS project. So it's the time for Sheraz Aslam to share the screen. Sheraz, okay, I can see you. If you can project your slides.
Yeah.
Okay,
can you hear?
Yes, it works.
Okay. And also, can you see my screen?
Yes.
Fantastic. Okay, let me introduce myself. So I'm Dr. Shiraz, working as a postdoc researcher at Cyprus University of Technology. Today, I'm going to discuss a pilot, a use case in AROS, Smart Edge Services for the Port Continuum. So as an AROS, so basically autonomous, scalable, trustworthy, intelligent European meta operating system for the IoT cloud continuum. So basically this is a 3-year project started from September 2022 until August 2025, in total 36 months. So we have 27 partners from 11 countries and more than 25 cities. So basically in AROS, the arrows needs to be performed so the closer to the data sources. So basically the fundamental purpose of arrows to perform processing near to the data in order to achieve higher efficiency, improve security and save bandwidth and guarantee privacy and increase autonomy. So the challenge of seamlessly integrating various edge technologies into a homogeneous continuum, for sure, it remains open. It includes cloud centrality and cost issues, the network management problems all around virtualization and security and trust issues. What are the key goals of arrows? So basically the fundamental goal of arrows is to design and build a virtualized platform, meta operating system for the IoT edge cloud continuum that is independent from underlying hardware and operating system. So it includes several use cases. For example, in manufacturing industry, the machinery, the renewable energy resources, and smart building, including energy efficient building, health and safe, sustainable smart building, and the last use case is maritime ports. Basically, this pilot is related to maritime port smart edge services for the port continuum. Okay, so basically, the maritime industry is very crucial nowadays, and this is completely responsible for international trade. However, the complexity of maritime logistic due to essential coordination of different actors. So basically, in maritime logistics, there are several actors. For example, the port, the port authorities, the container terminals, the ship owner, the shipping companies, and there are several other actors. For example, the shipping agents, third parties, and customer. So basically, this big coordination basically creates a complex environment in maritime logistics. So this is the seaside environment of the terminal. You can see here we have STS crane, we have yard area in the center where we can store the containers, and we have two types of machinery known as STS cranes and straddle cranes. So basically, the STS cranes are responsible to perform loading and unloading containers from the vessels, and straddle cranes are used to store the containers in yard area, or they can be used to load containers on the truck for land transportation. Okay, so as for digitalization of the port community, digitalization of the maritime logistics. So basically, there are four key pillars. Standardization. So basically, in standardization, so we have to perform efficient shipping, efficient logistics. In optimization, we have to reduce, for example, the waiting costs, the waiting time, delays in ships departure. As for profitability, of course, we have to reduce operating cost, for example, the berth allocation cost, Ukraine assignment, and several other costs associated with loading and unloading operation of vessels. So in future, so of course, to attract more customer, more shipping companies, and more operator to increase maritime logistics. So there are several challenges at the terminal. For example, we have several machinery and several entities at the terminal. They generate huge amount of data. Another challenge is the condition to have stable wireless connectivity with the vessels, with the port, and with other other stakeholder. Not possible to do end-to-end communication. High bandwidth plus low latency is required. External parties do not have digital connection of some time to at the terminal. So we have several tools for cost reduction at the terminal. Nowadays, we are trying to utilize IoT and big data platform to deliver intelligent insights based on real-time operational data, automatic yard operation, optimized vessel and berth operation, synchronized operators, radio-to-radio channels used by Cube Crane. And they can also help to reduce the cost of maritime logistics. So as a pilot, as a use case in Arrows, so basically we are three partner, Eurogate Container Terminal, Limassol, Cyprus University of Technology, and ProDevelop. So basically we are performing, we are Cloud Edge Continuum at the port of Limassol. So basically we have two key scenarios. The first one is predictive maintenance for handling equipment, and the second one is risk prevention by utilizing computer vision on the edge. So here is a port of the Limassol environment. You can see we have in total 7 queues. Now basically the two are a container queue. The name is container queue and container ro queue. Other are the passenger terminal basically to perform other operation, and two are in government use or not in basically public use. Okay, the first scenario, the predictive maintenance for container handling equipment. So basically, in this case scenario, we are considering to predict any fault in port machinery before its occurrence, in order to avoid high cost and to extend lifespan of the industrial assets. So basically, we are considering two types of machines here. The first one is cube cranes, and the second one is straddle carriers. So basically, we have installed several sensors, and we are collecting data from these machines. And based on this data, we are performing data analysis to find some useful insights. So we can use this data to train machine learning models to predict any fault before its occurrence. The second fault is risk prevention via computer vision in the edge. So again here we have basically two key scenarios. The first one is identify containers with damages. So you can see here, so we have several types of damages surrounding a damage, hole, rusty, bent, dent. So basically we have installed several cameras so at the terminal, and we are collecting live video streams from the cameras, and based on these video streams, we already have developed some computer vision based model to detect any damage in the container. And the second use case is the container seal. So you can see left side image on the yellow container. So basically we have to detect if the arrived container is properly sealed or not. So basically these two scenarios are considered here in risk prevention via computer vision and the edge. So here is a mapping of Arrow's architecture and services. So basically we have two key areas: Arrow's STS domain, basically the queue cranes, and the second one is straddle carrier domain. We're collecting data from these both domains, and then we are processing the both data on the edge for the predictive maintenance and computer vision based scenarios, let's say risk prevention and seal detection, exact seal detection from the images and videos. So right now, the current stage, so we have installed all the necessary equipment at the port. We also started data collecting from the port. Almost, yeah, we have started data collecting from October 2023. So we have installed various platforms. Let's say we are considering Node-RED for architecture of data. Then we are utilizing InfluxDB for time series data, and the data is sent from a port to our servers using MQTT broker. So as for second scenario, we already installed several cameras and we are collecting video streams from port, and we already have almost 690 images for container detection. So basically any damage detection in containers. So we already trained machine learning based models. So, and we are right now we have accuracy of map 50 0.95, although we have a low amount of data right now, but we are collecting that every day, and I'm sure we will have a good amount of data, and we will be able to implement and train a more machine learning model to achieve a higher accuracy. As for the damage detection, again, we have more than 500 images. Again, we already implemented Volo V8 model, and right now we have a lower accuracy in this scenario, damage detection in container. That is only 0.28. So yeah, this is only because of low amount of data. So yeah, we are trying to get more data. So basically the damaged data at the port of Limassol, Cyprus. So I hope we will have more data, and we will be able to train more machine learning model to achieve a higher accuracy. That's it from my side. So yeah, here is contact detail and the website of the project. In case of any query, you can ask now or maybe at the end.
Thank you very much, Shiraz, for the presentation. Yeah, I understand all these presentations were very information intense, so the audience has also needs some time to digest, but we'll have a dedicated moment for discussing some of these insights in a moment. Before going to that, let me introduce the last use case presenter, Salvatore Cipolla from MobiSpaces. So MobiSpaces is not part of the MetaOS cluster, but it's part of the EUCloudEdgeIoT initiative that Kolbu presented in the beginning. They are cooperating with us across various task forces, and so it's a pleasure to listen in also on their use case. So Salvatore, I don't know if you can
I
share
can
the
start.
slides. Yes, and
Okay. Sorry.
Share your own slides if you can. Okay, perfect.
I will do that. I will also try to be as brief as possible. Otherwise, I think we lose the panel. So yeah. Can you see my screen?
Yes.
Okay. So yeah, as said, MobiSpaces is an European project. Here you can find some information about the project. It will last for 3 years, basically. We have many partners from all over Europe. Inside MobiSpaces, we have Inside MobiSpaces, we have 6 use cases, and this is the first one. Basically, we are collaborating with AMT from Genova, which is the company that manages the urban mobility, basically in the city of Genova. Basically, it manages the fleet of public buses. Lorenzo is actually here. He's working on AMT with us inside the project. They recently added a fleet of electric buses and this is constantly growing. They're acquiring more and more electric buses, and while this is very important for the green aspect of transportation, it also poses some challenges, and that is the main reason why we are trying to collaborate on this, why we are working on this project on MobiSpaces. Basically, one of the main challenges is the fact that while there are many data, still they are difficult to acquire, and also they are difficult to interpret. So basically what we've done is work on this on this path. Here you can find the architecture of the use case, how it uses MobiSpaces. I'm sure you don't know anything about the architecture of MobiSpaces, so we'll try to explain a bit. We have a user, which is basically the control panel, the people who are working inside the control center of IMT. They will connect to MobiSpaces, which offers both user interfaces in order to make the AI that's happening inside the platform available to the user. And the platform actually will run some workflows, some pipeline that deals with the AI, the AI part of basically of the app of the project, and also the data management. So basically all the operations to acquire data from AMT and preprocess them, and so on. There is also a module inside MobiSpaces that works with visual analytics. Basically, as you may know, in mobility, often using visual analytics, visualizing basically maps and information on maps can be really useful to give insight to the control center of IMT. So this is what we're doing as well. And here on the outside, you can find the MT system, and also a data lake that we use to exchange data. Okay, so sorry, it doesn't go to the next slide. I don't know why. Sorry, I will try to share again.
If you want, Salvatore, I can continue sharing your slides. I have them. I'm sharing it now. Do you see it?
Yes, but I think Salvatore was just okay, he came back. Otherwise, maybe I can continue since I'm Lorenzo Montero from AMT.
Yes,
He is following our use case, but
Yes.
I see that he's here, so maybe he can start again.
Salvatore, can you hear us? Maybe he has some connection problems.
Yeah, so I can go on.
Yes, which slide?
The next one, I think.
Sorry,
Okay.
me.
No
Yeah.
problem, no problem, no problem.
Okay,
It's
I'm really sorry. Somehow my computer crashed. I don't know why. Anyway, yeah, we can go to the next slide. From this, there are some hidden slides, so we should skip them.
Yes.
So the fifth. Okay, perfect. So basically, the first thing we have to do, as was saying before, is to reorganize the data, because the data are really big. There's lots of data, and this was one of the main challenges actually to make them available to the AI itself, to the logic itself. Next slide, please. Then once we had reorganized the data, we try to solve the one of the actual challenges of the use case itself. This was actually, we call it scheduling problem. It's not like really like routing in the classical sense in literature, but it's really because routes actually inside the municipality of Genoa are established by the municipality itself. So basically, we know what roads, we know what stops a bus has to make. What we can do actually is to associate a bus to a certain trip, to a certain route, and to a certain number of routes. So consequently, and basically that's what we are trying to optimize here, to choose the right bus for the right trips, and make sure that basically the battery doesn't end in the middle of the trip. That's what we are trying to do. And please, next slide. This was done in three steps. Actually, we have a data retrieval part. Next slide, please. I'm sorry. I will. Basically, we developed some connectors in order to work with develop DBs inside of the project, and also to allow users to have a UI like the one you see is actually a screen from the project that without writing any code, basically you can build this kind of workflows. Next slide, please. Then we train the regression model. I won't go into technical details, but basically this model is able to predict how much time a bus will take for a certain trip based on the hour of the day, based if it's Sunday or if it's Monday, if it's summer or winter, and so on. Next slide, please. And then we use all this information that we trained on the actual MT data in order to solve the optimization problem using using an algorithm that's actually a genetic algorithm. So basically, these next slide, please. Basically, this algorithm will try to automatically optimize, automatically allow a automatically furnish a solution for the MT. I think we can stop here in order to save some time, because otherwise there would be technical details. I wouldn't go into details. Thank you.
Okay, thank you very much, Salvatore, and thank you to all the other presenters of the various use cases. Now we are approaching the end of the event. We are a little bit behind the schedule, but I hope this is not a problem, also because you know, this is an open discussion now, and we can embed any questions that come from the audience in the discussion, and so we don't have a separate slot for that later. So let's try and go more on, let's say, softer topics, because the presentations here had many technical details, and it's good because we wanted to give overview also for the people to understand a little bit the details, and maybe reach out to the projects that you want to synergize with or ask more information about. But now let's discuss about the effects, the benefits, the implementations, etc. So I want to invite the panelists to open your cameras. Okay, so I will try to have also a visualization that puts you all in the center. Let's see. So I'm pinning now Lorenzo from Mobi Spaces, Lorenzo Montero. Then welcome. We have Carl Miralpe from ICOS project. And then we have Yuri. Okay, I see you now from Nefele project. So I'm adding you as well. And Rafael Stalberg from, actually not a project, but he's been involved in Aloxi with the solution of GND. And so they have, they have interesting solutions to present to us today. So the first question I want to ask to all of you, so it's a general question to all the panelists, is, okay, we've listened to many use cases in different sectors, not different sectors, but, you know, different application contexts. Also heard about the challenges of implementation, but looking more on say business side, business perspective, performance perspective, do you have any examples of the benefits that you can achieve, or that you have already achieved thanks to the Cloud Edge and IoT solutions in mobility. So let's follow this question and let's follow this order, starting with Carl. Okay.
Good morning, everyone. I'm a member of FGC, which is a railway company, a public railway company in Catalonia, based in Barcelona. We have around 500 kilometers of railway lines, and we operate and maintain our main trains. And I'm part of the Department of Innovation of FGC and member of ICOS project. In our case, I think that the benefits that CI innovation enables the railway companies are quite clear in the sense of operational efficiency and safety, because we can monitor all the infrastructure and also our main trains. And at the end, we can optimize the maintenance task, transforming the actual corrective or preventive maintenance to a predictive maintenance. And this is the example that we take for the ICOS projects. As my colleague Isabella commented before in the presentation, for some years now, we were having some troubles with some subsoil instabilities in one of our lines, in a rural line. And this has been repeated a lot of times and repaired. So this means that usually every week or every 2 weeks, someone have to go there to do visual inspections. And also the cost that the repairs itself are needed. So it's a huge problem for us. But now we have installed all the sensors of the wall sensing platform and this area, and now we don't need to go there every week to check if everything is correct, because together with Cartographic Institute of Catalonia, we are monitoring all the area. And at the end, when the ICOS project can finish, we think that the solution, when it will be implemented, will allow that all the optimization and all the possibilities that CI cannot optimize all the control that we have of that area, and of course increase the safety of our operations, and we can also improve our capacity to respond to possible incidents and do so much better maintenance of that line.
Thank you very much, Carl. This is it's very important. You know, you mentioned efficiency, safety, incident management. I want to move to Rafael. Based on the solutions you're developing and you are offering to your clients, do you align with this type of benefits? Do you see others that can be achieved?
Yes, thank you for that question and happy to be here. So as G&D, we provide end-to-end supply chain visibility for the largest logistics companies. So DB Schenker, DAXA, GLS, and so on. And we really provide that whole offering from platform, middleware, but also the connectivity management, and then the actual device in the field. So solar-driven GPS tracker, which is also a gateway for Bluetooth sensors on the objects. And that allows us to provide a wholesome solution to our customers, where we can provide short-cycled movement tracking for logistics objects that are not power supplied or partially power supplied. We heard about railway wagons already. We are talking about dry containers, sea containers, so-called swap bodies that are used in Central Europe. We are providing almost real-time visibility on them. And by that, we can help our customers to that face excessive asset standstill times, late arrival times, damages to goods in the cool chain, damages due to shock events, to react to these challenges. So by this visibility, for example, it is possible for our customers to significantly reduce their costs of assets just by eliminating idle assets, by eliminating competitor use of those assets, by eliminating loss of equipment, by eliminating damages to the cool chain, and by eliminating theft as well. So there are many cases solved by this entire chain of solution.
Thank you very much, Rafael. Now let's hear the perspective of Lorenzo Mantero from MobiSpaces.
Yeah, thank you. I'm Lorenzo Mantero, and I work in AMT, that is the local public transport company of the city of Genova, Italy. and we are partners as a use case leaders in Mobi Spaces. And so thank you for inviting us. It's very nice to hear all these use cases, all these applications of the research. In our case, this kind of applications is very, very useful, and it's also some years that our fleet is substantially an IoT fleet, because all our vehicles, our 650 vehicles that run in the city of Genoa, are connected to our central offices through an automatic vehicle monitoring system that allows us to understand where they are, where all the vehicles are, to talk with the drivers and to exchange information. This is very useful for the management of the service, because it helps to understand if a bus is late, to take actions, to talk with the drivers and solve all the kinds of disruptions that can happen during the service. There are two problems that these kind of projects help us a lot to solve. One is that these systems, these IoT systems, store a lot of data in our servers somewhere that we don't use. So we have thousands of bytes of data of our buses that move around the city that would be very useful for what also Carl said before, so for maintenance, for safety, for many issues, but they are stored there. So in these projects, we don't only have IoT, but we have the analysis and the response to what IoT gives us. So we are very happy to participate to projects like Mobi Spaces for this reason. And then we have the electric bus part, that is a very new and a very important part for our company, because all European bus companies are shifting to greener fuels. So AMT has more than 100 electric buses, and these buses have a very different management with respect to the old ones. So it's time to renew our management system, and this project makes us understand better where the research is, where the technology is, and how to reach it and to apply it to our system.
Thanks, Lorenzo. Great. And now let's hear the same from Yuri.
Hello to everyone. My name is Yuri Mirnik from Luka Koper. Our company is managing the entire port of Koper, which is the only Slovenian seaport. We are partners in the Nefele project, and the motivation to join this project is to solve one very particular problem in the port. All those who were at least one time in the port exactly know how congestions, how different processes overlap one over the another. And one of the processes is delivery of containers from the container terminal in the different CFS areas in the port. This represents a very small amount in the total percentage of throughput of containers in the port. However, it still comes to around 500 to 600 containers that are daily delivered from the container yard to different warehouses within the port, and of course vice versa, in order to, let's say, put some additional value in the container value chain. And this, of course, adds a lot of problems in already congested port. And the idea in the Nefele project is how to use all these technologies which were, let's say, previously presented by colleague Rudolf, how to use this, and to, on one hand, to optimize the routing. So how to, let's say, understand the best way from the container yard to the CFS station in terms of routing times, truck utilization, errors that occurs, of course, and at the end, the CO2 emissions, which are, let's say, very important to this. We, let's say, around in the middle of the project, and results up till now are very promising, and we're definitely looking for a good results at the end of the project. So this is briefly an overview of this, and looking forward for additional questions later on.
Thanks, Yuri. Actually, before moving to the next question I had for you, let me pick up one that I see in the chat from Mike. This is general, addressed to all of you, and if any of you wants or has information to reply. Mike asks if you have managed to accurately and realistically estimate ROIs, return on investments, for these solutions. I don't know if you have enough data already for that. If anyone wants to comment on this, feel free.
At this moment, no. But during the project, also some rough estimations of implementation of this will turn on. But anyway, we have to understand that the TRL of level of this project is, let's say, targeting TRL 6, perhaps 7, but this is, let's say, the framework. So the answer is not yet.
Okay, thanks, Yuri. I don't know if anyone has different answers or
I can only comment on customer-specific implementation of the solution and the return that it brought to them, if that's of interest.
Yes. I think, yeah.
Okay, so over the course of the last 10, 12 years, we have observed that all untracked fleets that are implementing such solutions down to the sensor with the gateway devices and so on, that they are able to reduce rental assets, for example, by 5 to 10% at on an average, like they're in between. And there is a cost calculation that can be made per calendar day cost per asset, and then derive from that what you're saving each year on such a fleet reduction. For example, if you have 5,000 containers, you reduce the fleet by 500 containers. That is a cost of what, 6-7 euros per calendar day per container. So there is real return of investment, and actually it turns the fleets into a profit center.
Thank you very much, Rafael. Actually, I forgot to say some of the solutions that you are providing. We are finalizing a flyer to describe them, one specific case, and this will be distributed after the event together with the slides and other materials. So yeah, maybe more data can go also into that flyer. Let's go to another question I have for you. We have talked about performance, let's say, KPIs and potential results, but sustainability is also a key issue here. So my question now is mostly for Rafael, Lorenzo, and Yuri. If you can briefly comment on any sustainability benefits that you see from the implementation of these solutions. So let's follow maybe the same order we had before. So we had, I'm asking Rafael first, and then Lorenzo, and then Yuri.
Okay, thank you. So yes, of course, reduction of unnecessary asset movements leads to, in general, in the transport and logistics sector, to about 15% less fuel consumption. And we are heavily contributing to that with our solutions, as, for example, if you imagine a container fleet and you have hundreds of hubs where they are positioned, oftentimes trucks are dislocated or coming to a very far away hub to pick up some empty containers. And oftentimes it's not known that available assets are closer by. So just by giving target and actual number comparisons, these routes to relocate assets can be optimized. And that saves a lot of kilometers made on the road by heavy trucks with empty containers, and contributes to that fuel reduction. also booking systems that we offer, and in general, like the identification of assets on the own yard. Also, in terms of waste, maybe avoiding that cool chain is breached by fast reacting to an incident, or for example, in terms of theft, having the opportunity to fast react can avoid severe waste generation out of these processes. And maybe as a last point, we are operating these devices, these IoT gateways on a solar basis remotely. So there's SIM management, there's IoT device management. There are many things that increase the longevity of these devices. And because they are solar devices, there's already no battery waste over the course of a lifetime of 10 plus years. And we offer that in 10 plus year rental contracts with full warranty. So we're managing with these technologies that we heard about, the devices, that they can achieve this lifetime, and that is field proven.
Thanks, Rafael. Lorenzo?
Yes, as I was saying, sustainability is a key goal now for our company and for all bus companies. So our project is to make the whole fleet, so the whole 650 buses in the urban area, but also the 300 that run out of the city in the suburban area, to make them electric in the next years. So now we have more than 100. At the end of next year, we will have more than half of our fleet full electric. But this need a technological advancement. So it's not possible to work as we always have worked, because electric buses have lower autonomy, mainly with respect of the other buses. So it's difficult to manage them. With Salvatore, as Salvatore said before, we tried to build some tools that help us to well schedule our services, our buses, in order that they can run the exact time they can, the exact kilometers they can, without remaining on the streets, without battery, but also without not using them enough, so leaving them in the depot too much, because we are not sure how long they can go. And until now, research is not at the highest level in this field. So it's really something that is growing with the knowledge of the companies and of the bus companies and of the technological companies that go with them, helping them to understand how the battery. How is the battery behavior, how it reacts to the different paths, the different slopes, the number of passengers, and all the data that can interact with the battery level. It's a complex work, but really help to reach the sustainability goals. And then one more sustainability issue is the one of the end of the life end of the batteries. So bus battery have this problem, also car batteries. Electric cars, electric vehicles have the problem where to put and what to do with at the end of life of the battery. And so using the battery well is a way, at least, not to understand what to do at the end, but to make the battery work for a longer time. So to reduce the waste and the battery as a waste. And so we want to understand better how to use well the batteries to make them last long and and create less waste of bus batteries.
Okay, very clear. Thanks, Lorenzo. And now, Yuri.
Okay, the microphone, of course. Sustainability, of course, I fully agree with Rafael. Yes, each kilometer, each saved kilometer could be translated to euro per liter. And exactly this is the motivation. So within the Nefela project, the optimization tool will be developed, showing and at the end, of course, also showcasing how to let's say solve a typical salesman problem. Or this is the typical way. And in first year, the collection of information, integration of backend system and devices on the trucks took place. Now we are making a snapshot of the situation. And of course, during the lifetime of the project, this optimization tool will definitely show what kind of routing times reduction optimization can take place. And of course, at the end, this will be translated to euros and safe kilometers and safe CO2 emissions. And one thing, what was mentioned by Lorenzo, the electrical segment. Currently in the port, all the trucks are diesel-driven, of course. In Port of Koper, we have, let's say, quite a challenging plan to change diesel to electrically driven trucks, and outcome of the NEFEL project would also give us a fair comparison between the efficiency and costs in the diesel driven trucks, and of course some clear understanding in comparison to the electrically driven trucks, which was already in the test in our port earlier this year, and of course provides us very important data on this aspect. So sustainability, clear objective also of the NEFEL project in terms of end users, as port definitely in this project is.
Thank you very much, Yuri. So I have just one final question for Carlos, looking at the future, and then we wrap up. And thanks for everyone that's stayed, although we are a bit late. So I have a question about the future. Basically, Carl, if you have any ideas or plans about possible scalability of these solutions in the future.
Yes, sure. Well, everything is in constant movement, and more in a sector that, like railway, that it seems to be a bit old during a lot of time, but now they are starting to improve all the things. In our company, for example, we started monitoring the stations, and nowadays we can take control of all the elements on the stations from the centralized control center. So this allows us to optimize resources and reduce the cost. And at the same time, more or less, the trains also began to be monitored to improve their safety, but this was done by the manufacturing companies. And now this is used for us as a maintenance enterprise to improve our maintenance service and also the safety of our operations. But as I said, the infrastructure seemed to be always the forgotten part. So for some years to now, the monitoring of all the elements that surround it, from the ballast, the rail tracks, the electrical elements, substations, catenary, everything, start to be monitoring, and this allows us to improve the preventive maintenance, as I talked in the previous question. So now that we have all these things starting to be connected, we have to focus also in cybersecurity and cyber attackers, because railway sector is a critical infrastructure. So it's something, well, in general, the public transport can be considered as a critical infrastructure. So when we have more things connected, that what CI solutions allow us, this risk increase, and it's something that the enterprises related with this kind of solutions have to be a lot focused. And I would not want to forget that scalability also allows us to improve the interoperability between the different modes of transport and different modes of public transport. And I think that the main lines have to be in that sense in these solutions. And this is the main ideas that we are having in our enterprise to improve our service.
Thank you very much, Carl. And by thanking you, I also thank all the other panelists and the other speakers of today. Thank you also to the audience. I put just some final messages in the chat with links to our next events. All the slides and recordings will be on our website next week. And thank you again and have a nice weekend, everyone. Bye-bye. See you soon.
Thank you. Bye-bye.
Thank you very much.
Bye.